These are some notes from section, I believe it's 1.2C in Hawks. I'm going to write that down. This is 1.2C in Hawks Learning. This is simplifying radicals, and this is something that students continually struggle with. So you should have the notes from class. If you don't, you need to ask somebody to send you a picture of that or make you a copy of that. But I'm just going to go over some examples with you that you're going to find in Hawks. Again, you're going to have to get the notes from someone else. Let's look at this first one, square root of 121z squared. Now, here's a very important reminder. If you have an even root and you have an even power, but your answer is odd, then that particular part has to be in absolute values. So just the part that has the odd exponent has to be in absolute values. And I've told you, but Hawks is tricky here. So I'm going to try to show you some examples of how this works. So let's look at the first one. We know that the square root of 121 is 11. I hope you know that. It's on your factor sheet. It's on the square column. The square root of 121 is 11. So we just put a plain 11. But here the even, odd rule is going to come into place. Well, before I do that, let me refresh your memory. For exponents, what you do is you divide the power by the root. Power by the root. The way to remember that is the little toy called Power Rangers, PR. The whole number gets out, okay? And the remainder gets stuck. This is just review. Remainder gets stuck. So let's look at this simple example. I take the power, which is 2, I'm going to have to write it a little larger, divided by the root, which is also 2. So the power divided by the root gives me 1 remainder 0. What that tells me is that 1z is going to get out of the radical and no z's are going to get stuck. Okay, so I've got an 11 outside of the radical, just a plain 11. I have 1z outside of the radical, so I put a z outside of the radical, and nothing gets stuck, so there's nothing stuck in the radical. But here's where that even, odd, because 1 is an odd number, even, odd comes into play. If you start with an even root, you start with an even power, but your answer ends up being odd, which 1 is odd. Z to the 1 is an odd number. This, just the z, needs to be in absolute values. So when you type that in Hawks, you would type 11, then get the absolute value marker, z. Now, I'll be honest, I have found Hawks to be tricky here. Sometimes they don't want the absolute value bars. And if they don't, they'll say that's not needed on this particular problem. But try it if you have even, odd. Let's go to the next one. 3. You cannot take the square root of 3. It is an irrational number. But we can take care of these exponents. You divide the power by the root. The root here is 2. Now, we're going to have to watch out for even, odds, but I'll worry about that at the end. So if we divide 18 by 2, that is 9 remainder 0. Then I only have 1z. So 1 divided by 2 is going to be 0 remainder 1. So 9 y's are going to get out, 0 y's are going to get stuck, 0 z's are going to get out. In other words, none of the z's are going to get out, but that one lone z is going to be stuck. Okay, so in the radical, we could not do anything with that 3, so it stays in the radical. I have 9 y's out, so y to the 9th comes outside of the radical. I don't have any y's stuck. No z's get out, but 1 z gets stuck. Now again, go back, and you probably have to do this before you typed it in Hawks. Check your even, odd. Even, odd. That's the rule. Even, odd. So if you have an even root, which we did, and you have an even power, which we did on this 18, not the z, but the y had an even power, but it ends up odd, which 9 is an odd number, then just the y to the 9th needs to be in absolute value bars. Okay? All right, let's move over here and try a couple more. Move myself up. Determine if the following is a real number. Okay, so I've told you this already, but you can, uh-oh, my pen just messed up. Oh, let's see. Oh my goodness. I'm going to pause this video because my pen has messed up. Okay, sorry, I think I got that fixed. But just to review, you can take the odd root of a negative. Uh-oh, it messed up right there. Odd root. But you cannot take the even root of a negative. Okay, so right here, we're asking for the cube root of negative 27. You can take that because negative 3 times negative 3 times negative 3 is negative 27. So that is doable. The answer is negative 3. You can take the odd root of a negative. So that is a real number. If it had been impossible, in other words, if it had been the square root, let's say, for example, the square root of negative 4, that is not a real number. Now, we'll be studying that really, really soon, but the square root of negative 4 is not a real number. That is not anything that we can actually plot on our real number line. All right, let's move on. Simplify the following radical. Okay, remember your even, odd rule. So you divide the power, I'm going to just do it small, the power by the root, divide the power by the root. So this is going to be 2 remainder 0 on my x's. This is going to be 3 remainder 0 on my z's. And the fourth root of 81, you can find that on your power sheet. Go to the fourth root column, find 81, all the way over to the left, and you'll see that it's 3. 3 times 3 times 3 times 3 is 81. Okay, so notice the 81 was in the denominator, so we need our 3 to be in the denominator. X and Z were both in the numerator, so they need to be on the top. How many X's got out? 2. How many Y's got out? 3. And we don't have anything stuck. Now, I'm not going to put absolute value marks on here, even, odd. In my mind, you would need absolute value right here on this Y because it ended up being odd. It started out even and ended up odd. But I vaguely remember that Hawks does not require if there are 2 variables in the problem. Now, I could be wrong. I'm just saying I'm not sure. So check out if Hawks will accept absolute value on that Y. Again, you'll just have to practice that for yourself. Okay, let's do a couple more. We're now moving to, let me get my screen set up. Rationalizing the denominator. Again, if you do not have the notes, you need to have someone send them to you because this is very important. We look at this particular problem. This is a I'm having that same problem. It's like when I change screens, it messes up on me. All right, let's try it again. Let me pause. Okay, maybe 3 times is the charm. I apologize. We need to rationalize the denominator. Rationalizing the denominator means you cannot have any radicals in the bottom. No radical in the bottom. So the first thing you have to decide is this a monomial or a binomial? This denominator is a binomial because it has 2 terms. And so if you'll look on your notes, I gave a handout about this, you're going to follow the binomial side of the flow chart. Nothing can be simplified here. Nothing can be reduced. I cannot do anything to this problem except for rationalize the denominator. So if they are binomials, you're going to multiply the top and the bottom by the conjugate. Remember, the conjugate is the exact same term, so I still have radical y, so put radical y on the top, put radical y on the bottom. I have the exact same term in the back, which is radical 2, radical 2. But for conjugates, you change the sign in the middle. So if it was a subtraction, my conjugate is an addition. So there's the conjugate. Distribute. Radical y times radical y is radical y squared. Radical y times radical 2 is positive radical 2y. Now I'm ready to do my denominator. Again, this is on the notes, but for conjugates, you only have to do the first and the last, because what's going to happen is the outer and the inner will always cancel. So those two will always cancel, and you only have to worry with the first and the last if they are conjugates. Let me write that down, because some people think that you only ever have to do the first and the last. No, if they're conjugates. So, okay, my paper's getting really sloppy. Radical y times radical y is radical y squared. And then the last would be negative radical 2 times positive radical 2, which is negative radical 4. Now, I have a little bit of work to do here to simplify this. You know that addition and subtraction are opposites. They cancel. Multiplication and division are opposites. They cancel. Well, here's a short fact. Squaring and square rooting are also opposites. They cancel. So anytime you have a square and a square root together, I tell my students this gets caught up in a tornado. The square and the square root get caught up in a tornado, and you're just left with y. So we have y plus, I can't do anything here, so it's just radical 2y. Same thing in the denominator. A square and a square root are opposites. It gets caught up in a tornado, and it leaves me with y, and the square root of 4 is 2. So that would be your final answer there. There's nothing else you can do to simplify that problem. Let's try to get in one more. This one is a monomial. So you need to rationalize this denominator, but this time it is a monomial, not a binomial. So all you have to do, sorry, maybe 4 times is the charm. Okay, anyway, this is a monomial. So we need to multiply the top and the bottom by what's called the evil radical. Well, the evil radical is square root of 5y. Both of those are bad. Why are they bad? Because they are radicals in the denominator, and you cannot leave a radical in the denominator. So you're going to multiply your top, 3 times 5y. Now notice this is a free 3 and a radical 5y. They do not combine and become 15 because the 3 is outside of the radical, the 5 is inside. You can't mix those. In the denominator, though, they're both in the radical. So radical 5y times radical 5y is radical 25y squared. Well, we have to keep going. I can't do anything to the top. 3 radical 5y. I can take the square root of 25. The square root of 25 is 5, and then the square and the square root, remember, they get caught up in a tornado, and I'm left with y in my denominator. This would be your final answer. Now, why can't you cancel the 5y on the top and the 5y on the bottom? The reason you can't cancel them is because the 5y on the top is in the radical and the one in the denominator is not. So they're not like terms. You can mix radicals with radicals. You can mix free people with free people. But they don't jump in and out. So you don't jump in that radical, out of the radical. You're either in or you're out. And the people that are in can be combined with other people that are in. The people that are out can be combined with other people that are out. So I hope this is helpful. These are some example problems out of Hawks 1.2c. Combine this with your class notes for a full understanding of these concepts.